Assalamualaikum to all the panelists. I am Nur Akila binti Muhammad Azamuddin from AS253. Would like to present my final project, which is determination of nicotine in electronic cigarette liquids using dispersive liquid-liquid microextraction (DLME) coupled with gas chromatography-mass spectrometry. Electronic cigarette nowadays already contain nicotine in its flavor, which is, we know nicotine is a very harmful ingredient when it exposed to the human, especially through respiratory. There's some research that many have previously studied that the concentration of nicotine in other samples, especially in tobacco. But I would like to focus my nicotine content in e-liquids, which is electronic cigarette liquids. So here's some nicotine structure, and my focus for my project is that I will be using dispersive liquid microextraction to extract the nicotine content in e-liquids, which will be using GCMS to analyze the extractant. So the problem statement for my project is that the presence of nicotine in electronic cigarette liquids. Yeah, that's why we want to check how many concentration. And the second problem statement is that it need more research on qualitative and quantification of nicotine in tobacco and liquid product. So for the third problem statement is that varieties of the extraction methods of nicotine in a sample. And the fourth and last problem statement is that a more green liquid extraction method has been developed coupled with GCMS, which is a DLME extraction. Now let's go to the significant. What significant that I got in this project is that this project will be using off-5 method, one factor at a time for its parameter, valid parameter of DLME. And another significant is that DLME is an alternative to the green methods compared to the conventional method of solvent extraction. And this method will be a great future as it's rapid and simple. And lastly is that you can able to educate people, especially you, about the accuracy of the amount of the nicotine presence in e-liquids and whether it's identical as stated by the manufacturer. Now, the objective of my project, that the first objective is that to optimize and validate dispersive liquid microextraction for separation and per concentration of nicotine in electronic cigarette liquids using GCMS. Then my second objective for this project is that to apply dispersive liquid microextraction coupled with GCMS in nicotine extraction from e-liquids. Now we jump to the literature here. As you can see, for literature 1, nicotine exists in a salt. In nature, nicotine is ionized form, does not easily pass through organic membrane. Side effect of nicotine for adult is that the lethal dose is thought to be 30 to 60 milligram, while for kids it's closer to 10 milligram. Electronic cigarette liquid contain a total of 290 unique ingredients. There is various types of sample preparation of nicotine analysis, which is liquid extraction, SPE, which is solid phase extraction, SPM is solid phase micro extraction, and DLME. Now we shall continue with the methodology part. So in the methodology, there has several procedure that I arranged for this project. The first one is preparation of stock and standard solution, which is the nicotine standard solution. And then the second, we will prepare for the sample preparation and pre-treatment. Here in this step, there's the involvement of DLME extraction. Now we go to the optimization of DLME. So I set up two parameters to optimize the DLME extraction for nicotine e-liquids. So the two parameter is that the types of microextraction solvent. And the second one is type of dispersive solvent. This is the parameter of GCM. For method validation for this experiment, I will be using LOD, limit of detection, LO2, limit of quantification, precision, finally accuracy. Comes the result and discussion. Here's the result for the type of dispersive solvent. As you can see from the graph there, know that methanol giving a highest detection level of nicotine in the sample. As you saw at the screen is that chloroform giving the highest detection of nicotine in the sample compared to the rest, but ethyl acetate is not even considered extraction solvent at all, because when both ethyl acetate and dispersive solvent combined then injected into the sample, it doesn't giving two separate solvent, which is defeat the purpose of liquid extraction. So this is a validation method where by using the apply it to the real sample, which is the e-liquid considered as a brand A, which when we detect in GCMS, there's a 4.2 ppm and 4.34 ppm of nicotine in the sample. In conclusion, I able to optimize and validate the DLME for separation and pre-concentration of nicotine in e-liquids using GCMS. I also able to apply the DLME coupled with GCMS in nicotine extraction from e-liquids. The suggested method avoid time-consuming LLE process because it simplifies analyte separation by significantly decreasing the number of harmful solvent and reagent used. Therefore, DLME has been shown to be an environmentally friendly option for future analytical labs to consider when assessing nicotine from e-liquid samples in pre-concentration and determination. For recommendation, investigation further to optimize the optimization setting to test additional characteristics and aspects that may aid in enhancing the effectiveness of DLME as an extraction method for nicotine extraction in electronic cigarette liquids. That's all for my presentation. Here's my reference. Thank you for all the panelists that have been watched my video till the end.